Hey everyone, so this will be my last calculus video for you for the year. So as soon as you watch the video and then complete the lesson, you will be finished with me as far as grades go. Now next week on Tuesday and Wednesday, they will have times for you to come back to the school to drop off any items that you owe. So this would be like textbooks, including your calculus textbook. Some of you rented calculators that will need to be returned. Maybe you have items for another class, such as textbooks or whatever it is that you owe the school. There will be a time to come in and do that. So as soon as I know the specifics, I'll let you know, and I'll see you there next week. So we'll go ahead and get to today's lesson. So we're still doing U substitution. This will be our last lesson, of course. But notice that the integrals on this assignment are definite integrals, meaning that there are numbers that tell you your limits, the lower limit and the upper limit. So I'm going to show you today just two problems, and then you'll do your assignment, which also just has two problems, and then we'll be done. So you are very, very close to being all finished for me. Okay, so number one shows an integral sign, and then there's a 0 and a 1. Remember, these are the upper and lower limits. And then we'll have our function 2x squared, and then 4x cubed plus 1 to the 5th power dx. Okay, so we're still doing the u substitution. So you take the most complicated part and make that equal to u. So in this case, I'm going to use what is inside the parentheses, which is 4x cubed plus 1. So that will be my u. So don't do anything with the 2x squared. That will happen later. Okay, so then you're going to find the derivative of u. So you'll write du equals, and this is a polynomial, so the rule for polynomials is to multiply the exponent 3 by 4, so 3 times 4 is 12, and then decrease the exponent by 1, so it will be 12x squared. And then the 1 is a constant, and remember the derivative of a constant is 0, so you don't need anything for the 1, and then you put dx. Okay, so remember the goal is to substitute back into this. So you want to have something that we can put in for dx. So I'm going to divide both sides by 12x squared. That way we'll have that this value is equal to dx. So that's what we'll plug in over here. Okay, so we still have this integral, and I'll show you what to do with these limit numbers in a little bit. And then just keep the 2x squared there. But in place of this, you want to use u to the 5th power, and then instead of dx, we're going to use du over 12x squared. That's the substitution part. From there, we will simplify what we can. So notice diagonally, this 2x squared can cancel with the 12x squared. So this one would become a 1, and this one would become a 6. So think of the fraction 1/6. So you will pull that out in front of the integral sign. And you're left with u to the 5th du. Okay, so now you will do the integral part. So the 1/6 would still be there for now. And we'll deal with this later. Let's go to u to the 5th. So this is a polynomial. So remember the rule is to use a fraction, 1 over, and then it will be the exponent plus 1, so that will be 6, and then u will be to the 6th power. So remember the denominator should match with the exponent. And then you don't have the du anymore. Now typically we have written plus c, but those were for the indefinite integrals where there was no number up here and here. So what you will typically see, and I haven't done this very often, I think I did this earlier in the year. Sometimes you'll see a bar with the number 0 to 1, which means that you're going to plug in those numbers here after it's simplified. Okay, so don't worry about the bar, it's just telling you what numbers to plug in. So I'm going to simplify this, so I would have 1/6 times 1/6 would be 1 over 36. Remember that the u is the 4x cubed plus 1 that we were looking at earlier. So it's 4x cubed plus 1 raised to the 6th power. And then we have to evaluate that between 0 and 1. So we did indefinite integrals It was during the distance learning, but it was early on, so it's been probably a month or so ago now. What you will do is you will plug in the number 1 for x and get a value, and then you will plug in 0 for x and get a value, and then you subtract them. That is called the fundamental theorem of calculus, and you'll see that at the top of your note sheet. So that's what I'm going to do right now. I'm going to plug in 1, and I'm going to plug in 0 and subtract the 2. So I'm going to go to the calculator now that I have it set up. So let me set this down and bring you over to the calculator. All right. Hope you can see that okay. All right, so we're putting in the 1/36 at the beginning. And then in parentheses, it was 4x cubed. So you're gonna put 4 times the upper limit was 1 cubed. Then you will add 1. And that should be raised to the 6th power. Okay, so that's how it should look for plugging in 1. Now you are going to put a subtraction sign. Remember, this is the fundamental theorem of calculus. And now we're going to plug in 0. So it will be the same thing. 1/36. And then in parentheses, it will be 4 times 0 cubed. And plus 1. And remember, this has to be raised to the 6th power. So there we go. Your answer for the entire problem is 434. So that's exactly how you would type it in. And your final answer is 434. All right, so number 1 is complete. Put 434 as your answer for number 1. Okay, so we're just going to do one more, same process, but this will involve a radical. Okay. Okay, so for number 2, we have an indefinite integral, and we're supposed to go from 1 to 4. It's 2x plus 1 over the cube root of x squared plus x plus 1 dx. Okay, so we're doing u substitution still. So take the more complicated part and make that u. So I'm going to use what is inside of the radical, x squared plus x plus 1, and say that's u. Okay, then I'm going to take the derivative of u, so it would be du equals, so the derivative of x squared would be 2x. The derivative of x would be 1. And then the derivative of 1 is 0, since it's a constant. So then you would have dx. And we're going to be substituting something in for dx, so we want to divide both sides by 2x plus 1. So that'll cancel. So we'll have this that we can plug in for dx. Okay, so just keep the integral like it is. We'll deal with the numbers later at the final step. So don't do anything with the 2x plus 1. That will stay there for now. And in the denominator, you would have the cube root, but use a u rather than this. And then instead of dx, you're going to put in this du over 2x plus 1. Okay, so you will see that 2x plus 1 cancels with that 2x plus 1. So this time we're not going to have anything to pull out because they would just be 1. So I would have still the integral from 1 to 4, but I would have 1 over cube root of u. Okay, so throughout the year we have changed radicals to what are called rational exponents, exponents that are fractions. So u, if it's cube rooted, is the same thing as 1/3 power, u to the 1/3. But because it's in the denominator, that would be negative 1/3. So it would be the same thing as the integral of u to the negative 1/3 power from 1 to 4. Okay, so now I will go ahead and work on that integral. So it's a polynomial, u to the negative 1/3. So remember, you want to write it as a fraction. So I'm going to go from here over to here, so I have more space. So it will be a fraction, 1 over, and you have to add 1 to this exponent. So what is negative 1/3 plus 1? Let's think about that. So 1 is 3/3. So if you were to do negative 1/3 plus 3/3, you would get 2/3. So it would be 1 over 2/3 u, and then also to the 2/3 power. So it would look like that. Now we're not going to write plus c because this is a definite integral. So you'll have that bar that says we're going to evaluate it from 1 to 4. Okay, so now we'll just clean this up a little bit. So whenever you have 1 over a fraction, that means use its reciprocal. So rather than 1 over 2/3, I can say that's 3/2. And then u, remember, is the x squared plus x plus 1. But I want to write it as a radical rather than a rational exponent. So the denominator, which is 3, tells us that it is a cube root. So we're going to say 3/2 cube root. Instead of u, I'm going to put in what I had u to be earlier, x squared plus x plus 1. But remember, it was the 2/3 power, not the 1/3 power. So that means that everything inside of the radical will be squared. Okay, so this is going to be your answer, not the final answer, but this is what we will use in our calculator. So we're going to evaluate this from 1 to 4. So we're going to first plug in 4 and get an answer, and then we will subtract what we get for plugging in 1. So this is what I'm going to use when I go to my calculator in just a minute, plugging in those two numbers. So I'm going to set this down. So stop if you need to catch up. Okay. Okay, so we're going to put in 3/2. And then we need a cube root sign. So it's under math, and cube root is number 4 on most calculators. So it's 3/2 cube root. And then I'm going to use parentheses just like it looks on the paper. And I'm plugging in the number 4 first because that's my upper limit. So it's 4 squared plus 4 plus 1. Close the parentheses, and then that will have to be squared. Then you want to get out of the radical, so you'll have to press the right arrow on most calculators. And some of you might not have the same calculator I do. You possibly need to just close the parentheses and you're fine. But check and see if you get the same answer I do, in case your calculator is slightly different. Okay, then I'm going to use the subtraction sign, and then the other one is 3/2 again. Cube root is under math, number 4, and another parentheses. So now I'm plugging in number 1. So that one will be 1 squared plus 1 plus 1 parentheses squared. Okay. Yeah, so that would be how it should look, and press enter. So this is the correct answer. You should be getting 8.297. And if it's not a whole number in your assignment, always round it to the thousandths place. So your final answer for number 2 would be 8.297. Okay, so before we stop, I just wanted to say goodbye, because this will be my last video. I might see you when you drop off your textbook and so forth, but this will be the last time that I'm teaching you. And I just wanted to tell you how great it has been to be with you this year. And I know this situation wasn't ideal with learning in the last part, but I hope it went okay. I think if anybody still wanted to learn, that they were able to in my class, because I continue to try to provide you with lessons. So hoping you did learn something, even though it wouldn't have been as much as had we been in class. So Anyway, I hope that you all had a good year, and hope that you have a great year next year, more importantly. And whatever math class you take, I hope you do really well in it. And I'll still be around. I will be in the same classroom I have been for over 20 years. So come and say hello once in a while and let me know you're doing okay. And I will miss you guys. So take care. Bye-bye.